All right, welcome back everyone. This is a Calculus 2. In this video, we are going to talk about 3.3 trigonometric substitution. So in chapter 3, we've been learning about, a variety of integral techniques. So let's take a look at it. What is the new idea that we are going to talk about today? So here is the main idea that I really want to introduce today. So in chapter 3.3, we're gonna see a little bit complicated of functions. So for example, we talk about integral. You are taking the function, and then we don't know what type of function you are going to deal with. As I remember, it could be linear, it could be quadratic, it could be trigonometric, depending on the function form, we have a different integral techniques. Do you remember? So in here, 3.3, if your function f of x is getting involved in one of the forms such as radical a second minus x to the second, or if your function include radical a to the second plus a to the second, or if you have one of the form in the function, we're gonna use trigonometric substitution techniques, okay? So always we need to see the structure of the function. What kinds of function you are going to deal with? Is it composition function? Is it simple trigonometric function? Or it is a simple linear function? Depending on the function, we are using different integral techniques, right? So what I'm saying is here, if your function is getting involved in one of the form of this, we are going to use substitution form with the trigonometric function. So it sounds like a little bit abstract, but I will show you, and then you will have a better understanding, but hold up there, okay? So before I'm gonna introduce that particular weird form of the function, I'm gonna show you a couple identity that help us to find out the problem solving in an efficient way. So if you remember one thing, in the last video, I introduced the power reducing identity. Do you remember that? So cosine second x, you can reduce down the power, make it equal to 1/2 times 1 plus cosine 2x. So there's no more second power. Likewise, sine second x, you can make it equal to 1/2 times 1 minus cosine 2x, so there's no more power. One more thing I want to add here, tangent second x, that is the same as 1 minus cosine 2x over 1 plus cosine 2x. Just keep in mind, those identity will be used a lot, okay? And then another identity that I want to introduce, it calls a double angle identity. So you might be singing double angle to theta, like a sine to theta, cosine to theta, tangent to theta. So then this 2 theta is a little bit bugging me. I want to reduce down from 2 theta to theta. So if you want to do that, sine to theta is equivalent to 2 times sine theta times cosine theta. So there's no more 2 theta. And then cosine to theta, remember, it is the same as cosine second theta minus sine second theta, or 2 times cosine second theta minus 1, or 1 minus 2 times sine second theta. Lastly, tangent to theta is going to be equivalent to 2 tangent theta over 1 minus tangent second theta. So you actually learn those identities somewhere in trigonometry or geometry course. So I'm kind of like, remind you those identity, because you will use those identity to simplify whenever you have double angle or second power in terms of taking integral, so that we try to make it simplify. So just keep in mind, we're going to utilize those tools. So we're going to see a little bit complicated function that involve with those form of the function, okay? So let me show you the example. Let's go to here. So this is exactly what I want to show you. The question is, we are going to take the integral, right? And then the function is it is going to be take the integral 1 over radical 4 minus x second dx. So how would you be able to take the integral? So first idea you can think about, Professor Ben, should I have to use a use substitution? Yeah, you could try, but you will see the limitation. So let me try use substitution. So you feel like definitely 4 minus x second power, this function has been subbed into the radical function. So you will say u equal to 4 minus x second, and you're gonna take the derivative. So it's gonna be negative 2x, du will be negative 2x times dx. However, right, when you look at the original function, there is no x. It has only 1 times dx, and then I cannot simplify negative 2x dx. I cannot simplify it, right? I cannot simplify in terms of u, because what are you gonna do negative 2 and what are you gonna do x? So there is a limitation to use a use substitution. If you have x, luckily, then I can multiply negative to both of sides, then I can change dx in terms of du. But however, in this question, we don't have any further information. So the use substitution is not going to work because I don't have any further information. You see that? Because 1, we cannot change the negative 2x times dx to 1 times dx in terms of u. So that's why we have to think about another method. So that's what we are going to do, trigonometric substitution. So let's take a look at the format of your function. So when you look at the function, we have a 4 minus x second. So exactly this one is one of the form that I show you at the beginning. So a is a constant, x is the variable. So when you look at 4 minus x second, so I'm going to write here, the given function involves radical a second minus x second form. Does it make sense? So radical 4 minus x second is corresponding to constant second minus x second. Therefore, you can say a is going to be 2 times 2 is 4. And then according to the form, if you have this corresponding form, say that x is going to be a times sine theta. So my x will be a was 2 times sine theta. So simply, you're going to check. This is not going to work by use substitution. We are not going to be able to use a use substitution. We failed it. So that when I look at the form of the expression of the function, it involves a second minus x second with the radical. So therefore, I can define what the a is 2, and I can define what the x is 2 times sine theta according to the substitution form right there. So then we can think about the next step. So once you set it up, you are going to take the derivative of the x variable. So keep watching, dx over, we're going to take the derivative, this x equation in terms of the theta. With respect to theta, so sine theta will be cosine theta, you're going to keep 2, there's 2 cosine theta. It means dx is going to be 2 times cosine theta d theta. So you can substitute. Okay, so I'm going to keep making a space. So what happened? Our original question was integral 1 over radical 4 minus x second dx. Now I can change whatever the x variable in terms of the data, okay? Because we just took the derivative x equation in terms of the data. So what happened? Integral 1 over 4, and I told you x is now 2 times sine theta second power, and we just convert dx is now 2 times cosine theta d theta. So the original equation was with respect to x variable, but now the new one is with respect to the theta, correct? So now maybe we can solve this question. We can take the integral with respect to theta. So we can simplify from here. So now let me bring this one a little bit down. So this is, so now I can simplify. This means the same integral 1 over inside of the radical 4, and then 2 sine theta second power, that is the same as 4 sine second theta, and you have a 2 cosine theta d theta. Yeah, and then I can find out the common factor, so that is the same as 1 over 4, and then 1 minus sine second theta, and I keep 2 times cosine theta d theta. And then as you know, the 4, radical 4 is going to be 2, so I can take it out outside of the radical, so that's going to be 2. So integral 1 over 2, and then we still have a 1 minus sine second theta, 2 times cosine theta d theta. And then I can cancel 2 up and down. So that means 1 over 1 minus the sine second theta, cosine theta d theta. And then do you remember 1 minus sine second theta? It is the same as what? We know this is the same as cosine second theta according to the trigonometric identity. So cosine second theta plus sine second theta is 1. So 1 minus, or you can say cosine second theta is the same as 1 minus sine second theta. So I can say integral. So now 1 minus sine second theta is the same as a cosine second theta, 1 cosine theta d theta. Are you following? Then what happened? So let me just minimize a little bit. So now the second power and radical can be canceled, correct? So we can cancel radical and second power. So then it is going to be 1 over absolute value cosine theta, correct? Cosine theta d theta. So the cosine theta and the bottom cosine theta, they're going to cancel as well. So we have integral 1 d theta remaining. So now you can take the integral, which is a theta plus c. So this is a kind of like our answer, but I'm not done yet. Hold up there. Are you following so far so good? So what I'm doing here so far, we try to take the integral with this particular function. And then I try to solve this question with use substitution. It didn't work, right? So then 3.3 introduced another technique. Hey, if your function get involved, one of the form, in this time a squared minus x squared radical, use the trigonometric substitution. So a is going to be corresponding to, and x you can say it is a times the sine theta, that is a 2 sine theta. So this is where you are taking the derivative, and then we found out dx equal to 2 times 2 cosine theta d theta. And I plugging in. And then I simplify. I got theta plus c. But I want to go back to theta in terms of the x variable, right? So that's something I'm going to continue. So to find out that information, we're going to do a little bit of work. So do you remember we have x equal to 2 times the sine theta? So from here, okay, watch me. We can say, so we have x equal to 2 times the sine theta. And then if I divide it by 2, x over 2 will be sine theta, correct? And then do you remember in trigonometric functions, so let me a little bit minimize it. If you remember in trigonometric course, SOHCAHTOA. So sine theta, SOHCAHTOA. Sine theta is the same as, this is the angle between opposite over hypotenuse. So if you have a right triangle, there is a, let's say we have angle, the opposite side of the angle is the opposite side. The longest one is a hypotenuse, and then the other one is adjacent. So what they're saying is, Sine theta is x over 2. So x is going to be the opposite. 2 is going to be the hypotenuse, correct? So I can say hypotenuse is 2. Opposite is x. Can we find out the adjacent? Yes, we can find out the adjacent. So the adjacent, according to the Pythagorean theorem, so a little bit of a background, the opposite square plus adjacent square equal to hypotenuse square, right? So you say opposite is x squared, we don't know adjacent. And then 2 square is 4. So adjacent square will be 4 minus x second. And then let me just minimize this a little bit. So from here, what happened? So let me just go back. I don't need to, so I'm gonna just minimize. Okay, that's better. I'm gonna bring SOHCAHTOA. Okay, so here we can finish up. Adjacent is going to be radical 4 minus x second power because you're gonna put the radical to solve for adjacent. So that's going to be the adjacent. So anyway, by looking at the SOHCAHTOA, you can find out what the hypotenuse, what the opposite, what the adjacent in terms of the x variable. So my goal is to find out what the data. So I'm gonna highlight this one, x equal to 2 times the sine theta, correct? So what that means is x over 2 is sine theta. So how are you gonna solve for sine theta? So we have x equal to 2 times the sine theta. So we know x over 2 equal to sine theta. If you wanna solve for theta, theta will be inverse x over 2. So you can actually find out what the data was. So now I'm gonna just bring that information here. So theta we found out, sine inverse x over 2 plus c. So this is the answer in terms of the x variable you can get. So that's actually how you do this type of question. If you cannot use a U substitution, look at the structure of the function. And then in this function, you have corresponding, expression form, like one of the 3 forms. And then you can define what the a and x and take the derivative from there and then solve it in terms of the data and go back to the x variable. So that's all the step you can think about it. The reason why I show you the SOHCAHTOA, just a little bit of background, there's a possibility you can find out what the hypotenuse, opposite, and adjacent as well. Okay, but here we just need to find out what the data. Okay, so I hope this is not challenging question. I'm pretty sure you can get it, but don't worry, we're gonna keep practicing like this kind of question more and more. So hang in there, okay? So I'm gonna go down slowly and surely, okay? The more we practice, the better we feel. So let's take a look at the example 2. So I'm gonna try to help you guys, show you all the work. So let's go down slowly, okay? So always check the structure of the function. Okay, let's check structure of the function. So what happened here? I have an integral 1 minus 4x second. So you could try use substitution, but end up it's gonna be failing. It's not gonna work with the use substitution because you have a missing information to change it in terms of U variable. So I'm gonna check the structure because we are 3.3 help us, with which one is corresponding. So this is the form we can, matching. So actually this is 1 minus 4x second. So you feel like, 1 is 1 times 1, 4x is 2x times 2x. Professor Ben, this is a matching to number 1. But whoa. When you look at the first one, x to second power, there's no coefficient. So this 4 is bugging me. You should not have a 4 because when you look at the form, right, there's no coefficient in front of the x to second power. So I'm going to modify this equation, factored out with 4. So let's see what happened. Integral if you factor out 4 in the front, and then 1 gonna become 1 over 4, because when you do the distributive property, it goes back to 1. And then 4x second power, you factor out 4, it's gonna be x second and dx. So now, oh, beautifully, 4, radical 4, separated, and then you can separate 1 over 4 minus x second dx. And then we know that what happened, radical 4 is going to be 2. And I have a 1 over 4 minus x second dx. I can bring 2 to the front. And finally, I have 1 over 4 minus x second power inside of the radical. This is exactly what I want. This is going to be matching, right? These are going to be matching together. These are going to be matching together, right? Because now a is what? A second power is a 1 over 2 times a 1 over 2. So a is going to be 1 over 2, correct? And I don't see any coefficient in front of the x squared. This is a perfect corresponding. So therefore, this is x times x. And then x is going to be, you're going to substitute a times the sine theta. So a times sine theta. So your x is going to be 1 over 2 times the sine theta. So we have two information. A is a 1 over 2. X is 1 over 2 sine theta. So we good so far. Now what are you going to do? You're going to take the derivative. You're going to take the derivative of the x equation. So that means dx, you're going to take the derivative x equation with respect to theta. 1 over 2 sine become cosine theta. So dx will be 1 over 2 cosine theta d theta. So that's what I'm going to convert dx in terms of u variable later. Okay, so we good so far. Now we're gonna plug in back in terms of the data. So we have radical 1 minus 4x second dx. This is the same as we just found out this one. Integral. So there's a 2 integral 1 over 4 minus x second dx. Now I'm going to plugging in terms of the data. So this is the same as 2. What happened? 1 over 4. And then x is now minus 1 over 2 sine theta. And we just found out dx is what? Right there. 1 over 2 cosine theta d theta. So everything now with respect to theta. Beautiful. So let's keep going. I forgot the second power here. So let's keep going. 2 integral radical 1 over 4. This is a 1 over 4 sine second theta. 1 over 2 times cosine theta d theta. And then you can find out the common factor 1 over 4. 1 minus the sine second theta, and then 1 over 2 cosine theta d theta. Are you guys following? And then let's keep going. So now 1 over 4 with the radical becomes 1 over 2. So then 2, we have a 1 over 2, and then still 1 minus the sine second theta is inside of the radical, and 1 over 2 cosine theta d theta. Are we okay? So that's good, because remember, radical 1 over 4, it's going to be 1 over 2. So that's why I got 1 over 2. So I can simplify 2, they are going to be canceled, right? So the integral, and then one thing, 1 minus the sine second theta, this is the same as cosine second theta, correct? According to the trigonometric identity, and I'm going to bring 1 over 2 to the front, and then I have cosine theta d theta. Nice job. And what happened? The second power and radical going to be canceled, so it's going to be just the cosine theta, the second, and d theta. So that means we have a 1 over 2, forgot the integral, cosine second theta d theta. So it looks like we have a still second power. So watch me here. Cosine second theta go up, 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 up. Do you remember the power reducing identity? I'm gonna rewrite it. Cosine second theta is the same as, you can replace by 1/2 times 1 plus cosine 2x. So here, I'm going to say 1/2. This is the same as power reducing identity to theta, and we have a d theta. So this is, we know that power reducing identity. Are we okay? So let me minimize a little bit. And then what we're gonna do, I'm going to solve this integral. So we're gonna do one more step-by-step works. I'm gonna bring 1/2 to the front. So it's gonna be 1/4 integral 1 plus cosine 2 theta d theta. And then you can do expanded it 1/4 integral 1 d theta, correct? I'm gonna make a big bracket and plus integral cosine 2 theta d theta. We can separate it, right? Separate them. So what happened? 1/4, this is going to be theta, correct? And then please remember, I'm gonna write a little bit of note. Integral cosine nx. Remember last time, you're gonna convert, it's gonna be sine nx and you divide it by n because a chain rule, or sine nx, it's gonna be negative cosine nx. I need a little bit of space, and then the inside chain rule. So this is something you can find out the table. So therefore this one is going to be sine 2 theta, correct? So we have a sine 2 theta, and then you're gonna multiply 1/2. Are we okay? So that's what happened. If I just redo that. So that's what happened because of this. So let me keep writing. Let me keep, simplify what I can do. So let's see. We have 1/4 theta plus 1/2 sine 2 theta and 1/2. So what happened is, one thing you can also hear, I'm going to highlight it, sine 2 theta, if you go up, a little bit up, sine 2 theta is again same as 2 times the sine theta. You can reduce down the 2 theta to 1 theta. Okay, let's use double angle identity here. So here, one more time, sine 2 theta is the same as 2 times sine theta cosine theta, correct? And I do have here 1/2 theta 1/4. So they're all convergent. Integral cosine 2 theta becomes sine 2 theta times 1/2. And then this sine 2 theta is the same as 2 times the sine theta cosine theta according to the, what was it? Double angle identity. So that's what I told you. We're going to keep utilizing. So therefore, we can finalize it. 2 and 2 cancel. Yeah. So we have a 1/4 theta plus sine theta cosine theta. And then this is going to be 1/4 theta plus 1/4 sine theta cosine theta. That's your answer in terms of the theta. But I want to go back to the x variable, isn't it? This is with respect to theta answer. So what we're going to do, we need to evaluate what the theta. So here we utilize a couple identity to reduce down second power or second angle to the first angle. So power reducing identity, double angle identity. So keep in mind what I did. So we found out the answer kind of, but I want to go back to the x variable. So what we're going to do, go up, 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 up. Here, we know that x equal to 1 over 2 sine theta. So I'm going to write here. We know x equal to 1 over 2 sine theta from above the information. So you can actually solve for what the sine theta was, right? So if you multiply 2 both of sides, it is going to be 2x equal to sine theta. Am I correct? So therefore, you can solve for theta is sine inverse 2x. So we know what the sine theta, we know what the theta is a sine inverse 2x. So you can just plugging in. So the final answer in terms of the x variable, 1 over 4 sine inverse 2x plus 1 over 4 sine theta, right? So we know that theta is a sine inverse 2x, and then we already know sine x is what? Let me go back. So theta is this, and then we already know sine theta is 2x in terms of x. But do I know cosine theta? So let's evaluate it. So we know according to the right triangle, so you can find out the cosine theta SOHCAHTOA. SOHCAHTOA, right? So sine theta is opposite over hypotenuse, and they say 2x over 1. So let's say here's a theta. This is a hypotenuse. This is opposite. This is adjacent. So that's a 2x. And then what I do know, cosine theta is adjacent over hypotenuse. I need to evaluate what adjacent. So then according to the Pythagorean theorem, so hypotenuse is 1. Opposite is a 2x. So 1 square equal to 2x square plus adjacent square. So 1 minus 4x equal to adjacent square. So basically adjacent is going to be radical 1 minus 4x because you're going to put the radical both of sides. So we know cosine theta is adjacent 1 minus 4x over 1. That's the hypotenuse. So that's actually how you find out the cosine and sine. And actually you can also find out the tangent theta, SOHCAHTOA. Opposite over adjacent. So opposite is a 2x. And then adjacent is 1 minus the 4x we just evaluated. So you can find out sine theta in terms of x, cosine theta, and tangent theta. So we have the answer right there. Cosine theta, we need to also convert it to the x variable. So 1 over 4 sine inverse 2x, that's a theta. And then 1 over 4 times the 2x, I can simplify. 1 over 2x, and then cosine theta, we just found out, radical 1 minus 4x. So this is the final answer you can get in terms of with respect to x variable. So I know it's a little bit of long work because you need to take the integral once you convert it to the theta. So you're going to take the integral with respect to theta. So as you see that there were a couple identity you've been utilizing, power reducing identity, double angle identity. But at the end, I want to go back to the x variable. So therefore, you're going to find out what? Theta from the information we have. By using SOHCAHTOA, you can evaluate what the sine theta was, cosine theta, and tangent theta with respect to x variable. So once you have that answer, you can plug it in and you can go back to the x variable. So that's your final answer. Okay, so this is a very, very important question because this is one another technique, right? When you have a complicated function in terms of the integral, right? So I'm gonna keep practicing it. Hang in there. So we have a total like 6 examples. I'm gonna just solve everything. So the more you have, the better you got. So let's keep practicing it so that you have a better understanding. Got you. So I'm gonna go down the next ones. You can take a look at all the steps one more time. It's a very similar strategy, okay, in each question. So let's take a look at the next one. I'm gonna make a space. So, okay, I got you. So we have 4 minus x second dx. So I can modify this. This means we have a radical 4 minus x second power and 1 over x dx. Okay, we're gonna use the trigonometric substitution method. So as you see that 4x minus x second power with the radical is corresponding to the first one, so that I'm gonna use the sine theta substitution. So let's see what is going on. So this involves a square minus x square form, which is corresponding to 4 minus x second. So we can say a is going to be 2, right? Because 2 times 2 is 4. And then this is x times x. So x will be 8 times the sine theta, 2 times the sine theta. So you can find out those are 2 information. But here, let's say, take the derivative. So if you take the derivative, dx over d theta, it is going to be 2 cosine theta. So dx will be 2 times cosine theta d theta. So that's something you're going to convert it later. And then also you can find out more information. Here, we already know x equal to 2 times the sine theta. So x over 2 is going to be sine theta, which means SOHCAHTOA opposite over hypotenuse. And then therefore, theta is going to be sine inverse x over 2. You can find out many information from here. You can also find out the cosine theta and tangent theta. So cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. So if you think about it, we have the right triangle, and then this is the opposite, hypotenuse, adjacent. So they said opposite is x, hypotenuse is 2x over 2. So this is 2, this is x. So if you want to solve for adjacent, so hypotenuse according to the Pythagorean theorem, we have opposite square, adjacent square, correct? So 4 equal to x second. We don't know the adjacent. We're going to find out. So the adjacent, if you solve it, it's going to be radical 4 minus x second. So once you find out all the 3 legs, it's not that complicated to fill out what the cosine theta. Cosine theta now adjacent over hypotenuse. Radical 4 minus x second. Hypotenuse is 2. Tangent theta is what? Opposite, which is x over adjacent, 4 minus x second. So we have all the information. We know what the sine theta, x over 2. So I'm going to highlight it. We have sine theta is x over 2. Theta is sine inverse x over 2. Cosine theta is this. Tangent theta is that. So everything now you can convert it to the x variable. So something you're going to use this one at the end. And now we're going to solve for the integral. So let's go back to the question. So I'm going to keep going here with the same color. So we got it, integral. So this one is the same as 4 minus x is what? 2 times sine theta second power. And then we know there's a 1x and then there's a dx. So there is a dx, but the x is also 2. So I'm going to change this one in terms of the theta. 2 times sine theta. And then the dx we got 2 times cosine theta d theta. So that's what I converted everything in terms of theta. Are you following? So let's solve it. So integral, this is a 4 sine second theta, 2 cancel, right? And then it is going to be cosine theta over sine theta d theta. Actually, I need more space, but I'm gonna just, so 4, we can find out the common factor. This is a 4. So 1 minus sine secant theta. And we have a cosine theta over sine theta d theta. I'm gonna bring here in the next space. So if you bring it, we have a 4, 1 minus sine secant theta, cosine theta, sine theta d theta. Okay, we already know what's going on here. This is the same as cosine secant theta. And radical 4, this is going to be 2. We have an integral. And then this is going to be inside of the radical, correct? Radical 4 going to be 2. Radical 1 minus the sine secant theta is a radical cosine secant theta. And we have still cosine theta over sine theta. Again, what happened? The second theta, second power and radical going to be canceled. So we have a 2 cosine theta over sine theta d theta. And then I can bring 2 to the front. We have a cosine secant, correct? Over sine theta d theta. So now it's getting confused because we still have a second power. I want to reduce down. Are you okay with that? I want to reduce down. So here, I'm going to go back. So cosine secant theta, that is the same as a 1 minus the sine secant theta. So let's rewrite it. So it is going to be, so let me just minimize a little bit. So I'm going to minimize. Okay. So this is 2. Cosine secant theta, it is the same as 1 minus sine secant theta, correct? And we have over sine theta d theta. So this is the same. Why? Because I want to separate them now. So we can separate 2 different fractions. So it is going to be 2, 1 over sine theta, sine secant theta over sine theta, and then d theta. Better? So we can really separate it to big bracket, integral 1 over sine theta d theta. They're going to cancel. That's how I can reduce down second power to 1 power. So sine theta integral d theta. That's awesome. So now you're going to keep utilizing the trigonometric identity. 1 over sine theta. We know it is the same as cosecant. Do you remember cosecant theta? They are same. So let me change the color. So this is the same as cosecant theta. And then we have integral. So let me bring here integral d theta. And then you know how to take the sine theta integral. It is going to be negative cosine theta, correct? This is from the table. So we need to take the integral from the table. So just go to table. What is the integral cosecant theta? It is going to be ln cosecant theta minus cotangent theta. That's it. And then we have double negative positive cosine theta plus a c. So that if I rewrite it, this is a 2 ln cosecant theta minus cotangent theta plus distributive property 2 cosine theta plus the c, correct? We know everything. Go up a little bit. Go up. We know what the sine theta, cosine theta, tangent theta. So if you rewrite it, sine theta was x over 2. We evaluated cosine theta was a 4 minus x second over 2. We found out tangent theta was x over radical 4 minus x second. I want to find out what the cosecant and cotangent theta. So according to the trigonometric function, sine theta is a 1 over cosecant theta. Cosine theta is a 1 over secant theta. Tangent theta is a 1 over cotangent theta. Am I correct? So you can convert it. So now 2 ln cosecant theta is going to be opposite over sine. So it's going to be 2 over x, correct? And then cotangent is opposite over tangent. So we already know tangent. You're going to opposite 4 minus x second over x. And then we already know cosine, which is radical 4 minus x second over 2 and plus c. Good. So now I'm going to really simplify final. 2 and 2 cancel. So 2 ln 2 over x radical 4 minus x second over x plus 4 minus x second plus c. That's your final answer. I hope this is not challenging, but I'm pretty sure you got this. This is our third practice. Okay, it's the same strategy. You're keep reducing down whatever the second power or second theta. You're gonna keep reducing, utilizing the identity. And then here we are using a lot of trigonometry and geometry, identity we learned long time ago. We are reusing it. So that think about it. So these are all the steps you can solve it. All right. So I'm gonna hold up here. I'm gonna just do 2 more examples. That's it. Just 2 more examples, hang in there. So I'm gonna go to the next example, which is very, very similar what we done. So let me go down slowly. Okay. So in this question, let's take a look at it. So now you have a better confidence what we're doing. Okay, I love this question. It's exactly matching with the first one. So we know this involves a second minus x second is corresponding 9 minus x second. I don't see any coefficient in front of the x, so this is a perfect. And then this is a 3 times a 3. This is x times x. Therefore, a is going to be 3. And then x is going to be 2 times the sine, oh, not 2, 3 times a, 3 times the sine theta. So you can find out here, x over 3 is a sine theta, which is opposite over hypotenuse. So that you can also find out theta is a sine inverse over x over 3. So according to the Pythagorean theorem, you can find out all the information. Cosine theta, SOHCAHTOA, and then you can find out the tangent theta opposite over adjacent. So let's find out. So this is going to be the opposite, hypotenuse, adjacent. So we already know x is opposite. We know hypotenuse is a 3. So what would be the adjacent? Adjacent second power, opposite second power is a hypotenuse second power according to the Pythagorean theorem. So we are looking for adjacent second. This is x second, 9. So adjacent, if you solve it, it is going to be radical 9 minus x second. Try it. So therefore, you got it. Adjacent, 9 minus x second over 3. And then tangent, opposite over adjacent, 9 minus x second. So you have everything. We have everything. We know sine theta is x over 3. Theta is a sine inverse, x over 3. Cosine theta, radical 9 minus x second over 3. Tangent, we have everything. So this is good. Now we're going to do the real problem. Okay, so let's take the integral. Let's go. So we have the question. I'm going to go down. So we have integral 9 minus x second dx. So we're going to convert it to in terms of the data. So it is going to be 9 minus x is now 3 times the sine theta square, and dx we already know. So we didn't find out the dx. So I'm going to find out the dx. X equal to 3 sine theta. Dx over d theta. This is a 3 cosine theta, correct? So dx will be 3 times cosine theta d theta. So I'm going to plugging in dx now. It is going to be 3 times cosine theta d theta. My goal is to convert every x variable in terms of the theta variable. So that's what I did. And then you got 9 minus 9 sine second theta, 3 cosine theta d theta. So now you see the pattern, what is going to be happening. So there's a common factor, 9, 1 minus sine second theta, 3 cosine theta d theta. 9, radical 9, that's going to be 3, correct? And then we have 1 minus sine second theta, 3 cosine theta d theta. So we know everything. This is going to be, so 3 times 3, that is going to be 9, right? And then we know 1 minus the sine second theta. Again, it is the same as, I'm going to highlight it for you. This is going to be cosine second theta. And we have cosine theta d theta. So that is going to be integral 9. Cancel, cancel. Second power radical cancel. So it is going to be cosine theta. And we have another cosine theta d theta. So we have 9 integral cosine second theta d theta. So we have another second theta. So do you remember? We're going to use power reducing identity. Power reducing identity. So it's going to be 1 over 2, 1 plus cosine 2 theta. So we have 9 integral and d theta. They're going to be same. The cosine second theta is the same as 1 over 2, right? So this is the same as power reducing identity. So now you're going to separate it. Okay, I can separate it. I can bring 1 over 2 to the front. So 9 over 2. And then I'm going to separate them. Integral 1 d theta. Integral cosine 2 theta d theta. As you keep reducing down whatever you got. Same thing here. Cosine 2 theta. This is double angle identity. We can reduce down. So double angle identity set cosine 2 theta. Do you remember? Cosine 2 theta. But before we're gonna do it, actually take the integral first. I forgot to take the integral. So this is a 9 over 2. This is a theta. And then if you take the integral, so do you remember? I'm gonna write one more time. Cosine n theta d theta. You know that it's gonna be sine n theta 1 over n, correct? So it's going to be positive sine 2 theta and then chain rule 1 over 2. Got you now. So that's what happened. Okay. So now I'm going to simplify sine theta. Still we have a sine. We have a sine 2 theta. So this is exactly what we are going to use. Double angle identity. So it's that sine 2 theta is the same as, do you remember? 2 times no more double angle sine theta cosine theta. So I can rewrite it. 9 over 2 theta plus this part is going to be 2 times sine theta cosine theta, and we have a 1 over 2. So therefore, cancel, cancel. 9 over 2 theta plus sine theta cosine theta. Yeah. And you can do 9/2 theta plus 9/2 sine theta, cosine theta plus c. So this is the answer in terms of the data, but you can go back to the x variable because we know everything about. I know what the sine theta, I know what the cosine theta, plug in back. So therefore, 9/2. So we know theta was inverse x/3. And 9/2, we know sine theta, that was x/3. And then cosine theta, we just evaluated. 9 minus x second over 3 plus c. So simplify all the constant. 9, 3, 3, they're going to be canceled. So 9/2 sine inverse x/3. x/2 radical 9 minus x second plus c. Woohoo, we got the answer. So you see that? I'm not using any fancy technique. We are keep using the same identity, either power reducing identity or double angle identity. We are keep simplifying as much as you can. And then you will get the answer in terms of the data, but you need to go back to the x variable. So that in order to do that, find out what all the cosine, sine, and tangent. So it's going to help to find out the x variable answer. Okay. So I think this is a great practice, okay? I'm gonna do one last example. So I'm pretty sure whatever the question now, you can do it, okay? So I'm gonna go down slowly. So as you see that, this is 1 over radical x second plus 16 and dx. You see that? This is going to be corresponding to the second one. So you can try yourself. Try this one. I'm pretty sure you can say, now A is 4, X is going to be 4 tangent theta. So you can do the same work the rest of. Okay, try. Because I want to do a little bit challenging question 6. Okay. So let's look at this. Ooh, we have a little bit funky question. There's a power. There's a power. So I'm going to rewrite it. It means 1/1 plus x to the second, right? To the 5th over 2. And we have a dx. And then I'm trying to find out, the form that I can match. So let me keep reducing down. So let's see what happened. This is the same as 1/1 plus x second. So 5/2, 5/2, it's the same as what? 1/2 times 5. So I can separate it. 1/2 and 5 outside. Are you following? So I have 5/2, it's separated. 1/2 times 5. Second power is still there inside. And now what happened? These two are canceled. Second power, top and bottom, they're canceled. That's actually why I separate to see the structure. Or you can directly, separate, cancel it. So anyway, it is going to be 1/1 plus x to the second. Yeah. And then what happened? We cancel second, but wait. Before we're gonna actually cancel, let me just go back to the idea. Whoa. Before I'm gonna cancel, something I noticed. Do you remember? Radical means half exponent. So actually it means, I'm gonna keep writing. 1/, we have a 1 plus x to the second. Don't cancel it. This is second, so this is a half exponent. Help us to create a radical. Are you following? Yes. And then we have a 5th power and dx. How you feel? Are you okay with that? The reason why I didn't cancel, because we need to have a radical to correspond to one of the forms. So this is the second power. Watch that. This is the radical, right? So we keep second power inside and 5th power outside. Keep it. So now let's look at the format. This format, 1 plus x second, matching to the second form. So in here, you see that a is 1 times 1, so a is 1. And then x is going to be a times the tangent theta. So x is going to be 1 times tangent theta, just tangent theta. So we have this information. So this now, so this one, it involves a second plus x second. So we have 1 plus x second. So we have a equal to 1, x equal to tangent theta. We're going to use 5 later, but we see the structure now. And then theta will be tangent inverse x. Again, you can find out all the information. We need to find out sine theta, SOHCAHTOA opposite over hypotenuse, cosine theta adjacent over hypotenuse. So we know this is opposite, hypotenuse, adjacent. So tangent theta is x over 1. So one more time, x equal to tangent theta SOHCAHTOA, according to that, it is opposite over adjacent. So it is x over 1. So opposite is x, adjacent is a 1. What is the hypotenuse? Hypotenuse square equal to x squared plus 1 square. So hypotenuse is a radical x squared plus 1. So we got it. Opposite is x over hypotenuse, x second plus 1. Cosine theta adjacent, 1 over hypotenuse, x second plus 1. So you have all the information. Am I correct? So let me double check. We have what the tangent x, tangent theta, which is x. We know the theta is a tangent inverse x. Sine theta is this. Cosine theta is that from the Pythagorean theorem. We good. So hang in there. We're gonna almost done. So what happened the rest of work? We need to take the derivative from here, the given x equal to tangent theta. So if you take the derivative, so we have here dx over d theta. What is the derivative of the tangent? Do you remember? It is a secant second theta. Go to table. Dx will be secant second theta d theta. So we're gonna use this one when you convert it. So we have this information. Let me copy. So we start from here. I'm gonna delete. So we now convert it 1 over radical 1 plus what is x again? Tangent theta, second power. And we have a 5th power outside. And dx now secant second theta d theta. All right, so according to the identity, if you go up, 1 plus tangent second theta is the same as a secant second theta. So I can convert this secant second theta, correct? So if we do integral, what happened? Radical 1 here to the 5th, we have a secant squared theta d theta. So 1 plus the sine second theta is a secant second theta. So I can simplify what happened. The second power and radical gonna cancel. So we have 1 over secant theta to the 5th remaining, and secant second theta d theta right still there. We can keep simplifying. So we have 1 over secant theta to the 3rd power d theta remaining. Again, according to the trigonometric identity, 1 over secant theta is the same as a cosine theta. So therefore, it is going to be same as what? Integral cosine theta to the 3rd power, because of 1 over secant theta is the same as a cosine secant theta. Right? So if you remember now, this is something comfortable we learned in 3.2 units. You're going to separate it, second power, integral cosine secant theta, and 1 cosine theta. So this is a 3. You can break them into second and 1. and d theta. So now cosine second theta is the same as this 1 minus the sine second theta. And then you have a cosine theta, d theta. So 3.2 we learned, if you have, multiplication cosine times a sine or cosine power, you're going to break them into one of the even power. So now we're going to use what? Use substitution. U equal to sine, because the sine has been subbed into the quadratic. So du over d theta, cosine theta. Du will be cosine theta, d theta. So we almost done. This is 1 minus u second. And then what happened? Cosine d theta exactly. This is going to be du. So we have du. So that's it. We have u minus u to the third over 3 plus c. And then u was sine theta minus sine theta to the third over 3. And then you want to go back to the x variable. So we have all the information. If you go up, we know sine theta is x over x second plus 1. And then 1 over 3. Sine theta, we already know, x over radical x second plus 1 entire third power c. So this is a final answer in terms of the x variable. So hang in there. So here in this question, you should play a little bit. Oh, okay. We have to modify 1 plus x second. There's a hidden half exponent, that's a radical, so that it is going to be trigonometric substitution method. So you're going to keep going, find out sine, cosine, tangent, everything, and then plug in back in terms of the data, But here, think about it. We learned in 3.2 unit how to do this one, cosine theta. Third, break them, even power, and then use substitution. So you're going to convert it to the u, then go back to theta, then go back to x variable. Okay, so that's pretty much everything that I want to show you. And this one, same question. It's going to be matching with the third one, second. Think about it. Okay, so this one, try yourself as well. So whenever you have question, you can post to our participation discussion. You can post to discussion board. Help each other. If you have any question, share your work through that. Hey, I solved this question. I'm stuck in here. Somebody can verify. I can help you, or somebody can make a comment. Keep working together. Okay. So that's pretty much everything. 3.3. Okay. I show you all the steps. So now you need to practice. There's embedded video. If you go to quiz at 3.3, keep watching and keep organizing your work, and have a wonderful day. I will see you guys soon in the next video. Bye-bye.